Question 7. Evan works for a company that fits carpets. Carpets are usually measured in millimetres. A carpet is measured 7,800 millimetres long. How much is this in metres? Right, you need to know your conversions between millimetres and metres for this. So we should know that there are 10 millimetres in 1 centimetre. And then you should know that 100 centimetres are in 1 metre. So collectively, I've got the 10 and the 100, so that makes 1,000 millimetres in 1 metre. So if there's 1,000 millilitres in 1 metre, in 7,800 millimetres, there's just divide that by 1,000, so it's 7.8 metres. So that's your answer. So a carpet often requires an underlay, which is the same shape and size as the carpet, obviously. If a carpet measures 6,000 millimetres by 8,000 millimetres, what would be the area required for the underlay? Give your answer in metres squared. So if you've got just a regular rectangular carpet, this is going to be 6,000 millimetres, this is 8,000 millimetres. Now you can either do this times them and then turn it into meters squared, or I'm going to turn it into meters first. So 6,000 millimeters is actually 6 meters, and 8,000 millimeters is 8 meters. So I've just divided both of those by 1,000. So I know the area is you need to do one length times the other. So I'm going to do length times width to find area. So I need to do 6 meters times 8 meters to get 48 meters squared. So don't forget, area is squared. A room is in the shape of a cuboid. The volume of the room is 315 meters cubed. The carpet, which perfectly fits the floor, is 9 meters long and 7 meters wide. What is the height of the room? Now you need to know that volume, okay, so volume of a cuboid is length times width times height. So they've given you the volume, they've given you the length, and they've given you the width. We just need to find out the height. So if the volume is 315, they've told you the length there is 9, and they've told you the width is 7. So I can just substitute that into my formula, because I know volume is 1 times each side times itself, each side times the another, sorry. So I know that 315 is 9 times 7 times the height. You can do this a number of ways now. You can either take 315 divided by 9 and then divide it by 7, or I'm just going to do it a little bit easier way for myself, which is 9 times 7 is 63 times the height. I'm just going to do 315 divided by 63. Now, you can do that a number of ways. You can count up in 63s if you need to, but it's actually not that far, because you know that 6 times 5 is 300, well 60 times 5 is 300, so the height is just going to be 5, because 5 3s are then 15. Okay, so how many 63s go into 315 is 5, so the height is 5 meters. Height of room is 5 meters. Okay, Evan wants to fit a skirting board down one side of the room. The skirting board measures 416 centimeters, correct to the nearest centimeter. Evan needs to fit 2 of these boards together down the side of the room, measuring 835 centimeters, correct to the nearest 5 centimeters. He finds that the 2 skirting boards are too long to fit, just because it's only estimated measuring. Explain why this might have happened, and state the greatest possible distance between the length of the skirting board and the length of the wall. So let's just think about this now. We've got 416 centimeters. That is correct to the nearest centimeter. That means the smallest value it could be that rounds to 416 is going to be 415.5 centimeters. So it could be anything between these 2 lengths. And then the bigger length, the biggest number that would round down to 416. I know a lot of you might go to 416.4, but it's actually 416.49999999999 recurring. So we actually put 5 again for that one, because we just round it. Okay, so that's the upper bound. This is our lower bound. So the skirting board can measure any distance between here. Okay, so we need double that, so we need 2 skirting boards. And if we just double all those values, so double 415.5, you could just write those on top of each other and then add them up, gives you 537. Oh, not 5. Is it 537? Maybe I wrote my answer as well. Oh no, it's not 537, is it? Where have I got that number from? Oh, I know where I've got that number from. So double 415.5 is 831. It's because I've gone ahead for that. Then we need to double 416, which is 832 centimeters, and then double 416.5 is 833. So the skirting board could actually be anything between 831 centimeters and 833 centimeters. Okay, now they've said the skirting board is too long. Yeah, it's too long. So let's first now see how far the distance is of the wall. So this is 835. So if we took 835, correct to the nearest 5 this time. Okay, so this up here, upper bound of that is going to be 837.5, because it would actually be 0.4999999999999, which we just put to 5. And this lower one is 832.5. Okay, so you can see that if the skirting boards are going to be too long, so the skirting boards would be their maximum, well, this distance here of the wall could be just under, couldn't it? So if the skirting boards are 833, but the distance is only 832.5, then the skirting boards are going to be too long. So I've just proved it there, explain why, because the skirting boards could have been used the upper bound, and then the wall could use their lower bounds. You could write a statement. Should we write a statement just to say that? Skirting boards could be 833 centimeters, so upper bound, just put UB for upper bound, while the wall could be 832.5 centimeters, which is its lower bound. Okay. Oh god, just make us know me. Oh god, full marks is a lot. State the greatest possible distance between the lengths of the skirting board and the length of the wall. So the greatest distance is going to be if the wall was at its maximum and the skirting board is at its minimum. So I just want the difference basically between those numbers. Okay, so greatest possible difference is going to be the 837.5, take away 831 to give us 6.5 centimeters, because the wall could be at its biggest, skirting board could be at its smallest, and that would give you the greatest distance between the two measurements. So that's all about upper and lower bounds if you wanted to go and revise that. Okay, question 8. You said, I didn't say, you said, works for a taxi company. He charges a fixed rate of £3.20 plus an additional £1.50 per mile. How much does he charge for a journey of 19 miles? So it's £3.20, add the number of miles times 150. So 19 times our £1.50. You can do 19 times 150 a number of different ways. I would probably times it by the 20. So I'd do 20 times £1.50 and then take away the £1.50, which is £28.50. Then I'm just going to add my 3.2, so add my £3.20, and I get £31.70, and that is this one here. Okay, so to times 20 and 1.5, I'd probably do 19 times 1.5. I do 20 times 1.5, so that's 30. Then take away my £1.5, which is 18.50. It's an easy way to times by 19. If you're wondering how I did that. Oh wait, I wrote here where I shouldn't really have I? Oh, this shouldn't really be here. Let me see if I'll just move this over there for you. So that belongs to that one. Okay. You said charges £19.70 for a journey. By forming an equation or otherwise, calculate the journey distance in miles. Okay, so what he does is he does should we put the cost, or the charge, is £3.20 plus £1.50 per mile. So that's not quite an expression yet. I'm just going to change a bit more into algebra. So I'm going to put C for cost, £3.20 plus my £1.50. I didn't put pounds on there either. 150 per mile, so we'll put 150 M. Okay. And now it costs £19.70. So C is £19.70 instead. Yes, C equals 19.70. So I'll have 19.70 equals 3.20 plus 1.50 M. Have we got to calculate M? Yes, we do. Right, so this is solving an equation. So my first step is to get rid of my £3.20. So I'm going to, because it's positive, I'm going to subtract it. So I'm going to take it away, take £3.20 away from £19.70. So 0, 5, I'm going to lay this out very straight, have I? 6, 1. So I've got £16.50 is 1.50 M. So I just need to do £16.50 then, divided by my £1.50. You could do that, number of main divided by 1.5 is not too hard. So £16.50 divided by the £1.50. How many £1.50 goes into £16.50? You could keep count, wouldn't take you that long. And it is 11. So it is 11 miles. We're in miles, aren't we? Yes. Okay, I didn't even see that question earlier. Okay, purple paint. Oh, I didn't like this one. Purple paint is made by mixing blue and red in the ratio of 5 to 3. Because you think, oh, it's just a ratio question. But actually, it's really not until the next one. Midnight Mist is a special shade of purple made by increasing the proportion of red by 3/4. So you increase just the red by 3/4. I'm not touching the blue. I'm just going to add more red, basically. I'm going to add 3/4 more red. What proportion of blue and red paint expressed in simplest form is required to make Midnight Mist? Now, let me just zoom in a little bit. This is the way I did it. If you've got a different way, or if you want to ask your teacher a different way, that's absolutely fine, but this is just the easiest way I could find, or I could think of. So we got our ratio 5 to 3. Now I want to increase, because it wants to increase, I want to increase the 3 by 3/4. Now I can't increase 3 by 3/4. I could, it'd have a decimal in. We don't want decimals inside ratios. So I'm going to make these numbers a bit easier to work with. And the quickest, easiest way I can think of is to times them both by 100. So making this 500 and making this 300. Just so, because I know I can increase 300 by 3/4. So now I want to increase this 300, because this is the blue, this is the red. So I want to increase the 300 by the 3/4. So I've taken that proportion, I've taken the 300, and I want to increase it by 3/4. Now to find 3/4 of 300, I need to do 300. I divide it by 4, so I can half it again. So half of 300 is 150, half of 150 is 75. And then I want to times it by 3. So I want 3 lots of 75, so I do 75, add 75, add another 75, which is 225. And I want to add that on. So I'm going to do my 300 add 225, which is 525. So I've now got 525 red. So I still have the same amount of blue, because obviously if you add more red, it turns purple, doesn't it? So I've still got the 500 blue from earlier, but now my red has gone up to 525. So this is my, this is now my ratio. Okay, so I've got 500 and 525, and it wants it in its simplest form. So I need to simplify this. Now, you want the biggest number that goes into 500 and 525. The biggest number that points out to me, I know a 5 goes into it, so if you wanted to do 5 first, but it's easier if we do 25, because 25 goes into both those numbers. So I'm just going to divide both of them by 25. So you know 25, 25, 25, and 25 is 100. So you know 4 lots go into 100. But I need 500, so I need 4 lots of 5, which is 20. So this one becomes 20. And then this is just 1 extra 25. So there's the 20 plus the 1 extra which is 21. So my ratio, my answer is all the way by year, so a lot for 3 marks, but really, is 20 to 21. I think I've done that right. We'd know if we'd done right, because if the next bit would be wrong if we hadn't done right. So, Lacey wants to make 2,050 millilitres of midnight mist for a customer. Calculate the amount of red paint she will need to make the required amount of midnight mist. So this is sharing ratios now. Something we should know how to do. You can use the bar modelling method, but it's actually easier not to do that because our ratio is 20 to 21 and I'm not drawing out 41 boxes. Okay, so the easiest thing to do when we're sharing a ratio, so remember this is blue to red and we only need the red one, is to add your ratio. So step 1 is to add ratio. This is how I've taught it before. So I'm going to do 20, add my 21, which is 41. Step 2 then is to take your amount and divide it by your answer for number 1. So I'm going to take my amount, 2,050, and divide it by my 41. You could do this a number of different ways. You could use the bus stop method. It actually wouldn't take you that long using the bus stop method, but I've showed you that in an earlier video. This is only 50. Okay. And then step 3 is to take your ratio, but I only really need the red one, and times it by your answer from number 2. So each one part is 50. I only need 21, so I actually only need to do 21 times 50. Again, that wouldn't take you long. Times it by 5, and then add the 0 on the end. So 21 times 5 is 105, and then add your 0. Okay. So 1,050 millilitres of red paint. Okay. If you did the other one wrong, so if you did A wrong, and you had a different ratio, so if you didn't have 20 and 21, as long as you used that here and did the same methods, you'd get full marks. So you won't get penalised for getting your last one wrong for this one. You still get all 4 marks if you've used your ratio. Okay? Lacey makes up another batch of midnight mist using 700 millilitres of blue paint. How much red paint would she need? So again, this is our ratio that we found out in part A. Again, if you got this bit wrong, just use your ratio. Okay, so this is blue, this is red. 700 millilitres of blue, so this time she's got 700. We need to see how much red. All you need to do is how do you go from 20 to 70. So do your 2s, 20s, until you get 700. How many 2s go into 700? But basically half 70, which is 35. Not too bad. So it's timesing it by 35 to get 700. So we're going to do 21 times 35 to get 735, because it's like 20 and then an extra 35. Okay. Right. Yayan wants to travel to New York from Cardiff Airport. He lives in Newport. His plane leaves at 3:12 p.m. He wants to arrive at the airport 2 hours before his flight is due to leave to allow him enough time to check in and clear security. That's a long sentence. So 2 hours before here, I haven't even read the question, not all of it, but 2 hours before here is 1:12 p.m. He allows himself 30 minutes to travel from the nearby train station to the airport, so we want 30 minutes before this time, so we got 1:12. Take off 30 minutes, leaves me with 12:42 p.m. I don't even know the question yet. He catches the latest possible train for Cardiff, to be sure arriving at the airport on time. Part of the train timetable is shown below. What's the question? What train should Yayan catch? Okay, so he wants to be in Cardiff by 12:42, so we can't have that one, his train's going to leave. Can't have that one, can't have that one, plane going to leave, can't have that one. We can take that one, you just have a bit of extra time. So he wants to catch the 11. What time train should he catch? He'd catch this one. And that is going to be in the morning, isn't it? 3:30 a.m. Obviously not at night. The actual time to travel from the train station to Cardiff... From the train station in Cardiff to the airport is 24 minutes. Calculate the total travel time from Lewin. They've changed his name now. Was that always an L? No, that wasn't always an L. Lewin? I don't even know how you would say that. calculate the total travel time from Lewin departing Newport to arriving at Cardiff Airport. What crazy people. Right, so from departing Newport, so we know he's going to catch the 11 o'clock train, which arrives at 12:35, so we need that travel distance. So from 11 o'clock to 12:35, well, that's 1 hour and 35 minutes. Then it takes him 24 minutes to get from the station to the airport, so we need to add 24 minutes, so that's 1 hour and 59 minutes. I feel like I've done that one wrong for 3 marks. Oh well. Right, Molly is calculating how much tax she will pay on her income for the next financial year. Her gross income will be 57,000. Right, this is for everyone, so you should really get used to this. Everyone has a personal allowance. So you don't pay tax on anything up to 11,000, so you get that tax free. You get 11,000 in your pocket all the time. The basic rate, so from then 11,000 to 43,000 is at 20%, and then the higher rate is from 43 to 150 at 40%, and she's not in the additional rate, so we don't really need that. So we only need these 3. Okay, so she doesn't pay any tax on the 11,000. So we don't need to calculate anything like that, because we're calculating how much tax she pays. Then the basic rate, so she earns 57, remember? So all of the money between 11 and 43, she's going to pay 20%. So basic rate, so we got 43,000 to 11. I'm not going to include the 1 because I can't work out 319999. So we got 32,000, and we're going to calculate that at 20%. So 20%. I know 10% of 32,000 is 3,200. Oh, 1 times that by 2. So that's 6,400. So she's paying this much tax. And we want the higher rate. Now don't forget she's only got 57,000 and the higher rate doesn't start until 43. So we take those away and we're left with 14,000. So we want 40% now, don't forget. So I know that 10% is 1,400. Therefore times that by 4 to get 5,600. So that's how much she pays in the higher rate, which is just almost. All we gotta do, so total tax to pay is add those together. So 6,400, add my 5,600 to get 1,200. Oh, that's alright now. Yeah. What will Molly's income be after she has paid tax? Okay, so this is how much tax she's paying. We just need to know how much money she's taken home after that. But she's got to pay national insurance and then her pension and all that jazz, so she doesn't actually get this money. What should we say? Should we say income? I missed the C there. Income after tax. So we take her 57. Sorry about the noise. And we take away the 12, which leaves us with 45,000, which she can take home. But she's got to pay her bills and her rent and all that jazz. So she doesn't actually get 45,000 by the time she pays for everything. Okay, next question, which is actually a little bit already filled in. Oops. Okay, Sarah's conducting research into the marks students in her class receive in their maths exams. She collects the following data. So there are marks between 2 people have between 0 and 10. 4 people have between 11 and 20. 6 people between 20 and 35 marks. 9 people between 36 and 50, you get the idea. 7 people between 51 and 60, and 3 people between 61 and 80. Complete the cumulative frequency table above for Sarah's data. So, I don't know why that's already in there, but cumulative means a run-in total. So, you basically, the marks less than 10, let me just get rid of this. The marks less than 10 are 2. Okay, so there's 2 people who've got less than 10 marks. Then we want to know, so this is our upper here, we want to know how many people marks are less than 20. So we got this 4, but we also got this 2, so for now it's 6. Then we want the marks that are less than 35. So I got the 6 and the 4 and the 2. So I just add another 6 to the previous one here. So I got 12. Then we're going to add the next extra 9. So we've got marks, less than 50, which is 21. So I do 9, 6, 4, and 2. Then the marks that are less than 60. So in total, how many less than 60? Add the 7 to get 28. Then we want the total marks that are less than 80. So this is basically the number of people. Add my 3 to get 31. So it's a class of 31. Okay, can you see it's a running total? So each time I just add an extra 1 here. So that's my 2 marks there. Construct. Oh my gosh, I don't like this grade. Construct a cumulative frequency diagram for the. Oh my. Right. We need. You want the marks going along the bottom, and then the cumulative frequency on the side. So the cumulative frequency is always on the side, and the marks are going to go along the bottom. Now the marks are in 80. 1, 2, 3, 4, 5, 6. Oh, wow, that's poo. Oh my. Oh dear. Right, this is going to be horrible. Let me zoom in. The marks go up to 80. And there is not 80 spaces. So I'm going to go up in 20. So this here is going to be 10 marks. This is going to be 20. It's going to be 30. This is going to be 40. This is going to be 50. This is going to be 60. And this is going to be 70. And this is going to be 80. Cumulative frequency always need to go on the side. So what is the deal? What does cumulative frequency go to? 31. What can we do? 10, 20, 30, no. 5, 10, 15, 20, 25, 30. Oh, we'll have to do 5, 10, 15, 20, 25, 30, and then this will be 35. So 31 will be up there. Right, you want to plot your points. So at 10, you're going to plot 2. So at 10, oh gosh, this is going to be horrible. At 10, you're going to want 2.5 is there, so 2 is probably going to be about there. Then at 20, you're plotting 6. 5, 6, about there. And then 35 is the next one, isn't it? Ugh. Look at V. 35 is 12. So in between here, 10, 11, 12, that's about there. Ew. 50 then is 21. So going across 50, up 21 is about there. Mine are not very accurate at all. This is horrible. Then at 60 is 28. So 60, 20, so about there. And then 80. Oh my. 80 is 31, which is about there. Oh, I don't like that. Right, it curves. It's not a straight line. Oh my. Okay, it's not. Oh, messed up a little there. That's what cumulative frequency graphs should look like. They go like that normally, like a nice curve. Alright, it'll have to do. Okay, so that's the cumulative frequency diagram. Lovely. 5 marks. You probably get the 5 marks for like the scale, the labelling of this, etc. The plotting the points, the joining them up with not a ruler. Okay, the hard stuff, cumulative frequency. Okay, here's another one. Okay, they have not joined that up with a ruler. What are they even doing? They always do stuff like this. They join it up with a ruler and then they'll ask you what's wrong with it. And you'll be like, well, it's joined up with a ruler for start. So, okay, Sarah's friend Joshua is in a different class. He surveyed his class. Also, the cumulative frequency diagram for his results are shown below. The maximum mark was 65 and the minimum mark was 20. Draw a box and whisker diagram for Josh's class. Okay, so box and whisker diagram, we're going to need 5 bits of information. We're going to need the maximum, which they told us was 65. We'll need the minimum, which they told us was 20. Then we need the median, the lower quartile, upper quartile. We'll get onto that there. So, what did they say the maximum was? 65, but we'll see what we can get to. So let's do like 10, 20, 30, 40, 50, 60, 70. There we go. So this is 0, 10, 20, 30, 40, 50, 60, 70. So these are our marks. Okay. The maximum mark was 65, so it's 65 is my nice maximum mark there. Minimum mark was 20, so 20 is here. So these are my end points now, end of the whiskers. Right, to find the median, you need to take the total amount of people that were asked. So the number of students was 30. Then we go median, middle. So I half 30, which is 15. So I go across 15. I have a ruler on this app. Like, what am I even doing? Go across 15, see? And then down. Wow, that's not a nice straight line, is it? Why is it doing that for? This is why I don't like technology. Okay, let's freehand it. So down there, let's say that's smack bang in the middle. We'll say 45. So this is our median here, 45. Now we're going to need our upper and lower quartiles. So if this is the halfway point, lower quarter is going to be a quarter. So I want to half 15 basically, which is 7.5, which is going to be in the middle between 10 and 5. See if a ruler will work this time. Oh, it's wonky. Oh, okay, it's gone on the point. Oh, there you go. We'll say that's smack bang in between 30 and 40. So let's say 35 for the lower quartile. Upper quartile then is going to be 3 quarters. Okay, so we've got half, 1 quarter, 3 quarters. So we could just basically we can add 7.5 to 15, which is going to be 22.5. So basically in between 20 and 25. So we're going to go across here. Ooh, lovely. Down here. Again, that's like, what is even happening up there? Oh, please, like, use a ruler and concentrate when you're doing this. So between 50 and 60, let's say that's 55. So that goes here. So we box these middle ones. And we can whisker them to the edges. So this up here is our max. This here is our minimum. In the middle was the median. This is our upper quartile. This is our lower quartile. And you can find the interquartile range from doing that. I wonder if they'll ask us this now. Probably not. They'll just ask us to do a comparison because we've just done 2. Okay, last one. Joshua says that his class have performed better than Sarah's. Using calculations and reasons to support your answers, show whether or not you agree with his statement. Okay, I'm probably going to agree, but then he used a ruler, so I don't know. Let's compare some calculations first. So we've got Josh and we've got Sarah, wasn't it? Right, let's compare. We compare data. We compare averages. Let's compare their median. Now we knew Josh's, if I go back, Josh's was 45. So Josh's was 45. Sarah's, I'm sorry if I'm going to like keep going back and forth here now. Sarah's, now her top one was 31 and halfway between that is 15.5, so we'll go 15. Go across, read down, what's that, about 40? I mean, each one is 2, so 42. Is each one 2? How many is in between there? Oh no, each one is 1. Yeah, but where is it really? I'm going to go with 42 anyway. Okay, so Sarah's is 42. Okay, Josh has a higher median. Okay, so his might be a little bit better. Best not drawn with a ruler. Let's compare their lower quartiles. So we know Josh's was, lower quartiles here was 35. I can't bother to keep going back and forth, so I'm just going to tell you this one. Sarah's is 29. Upper quartile, Josh's was 55, history found out. And then Sarah's, I think I did measure it to be the exact same on the sheet. So I'm going to say that's 55. The interquartile range. Now to work out your interquartile range is your upper quartile. Take away your lower quartile. Okay, so I'm going to do the upper, take away the lower. So for Josh, 55 take away 35 is 20. And 55 take away 29 is 26. So he has a lower interquartile range. That means like basically the majority are like closer together. I mean, I would say yes, I agree with his statement. Like he said, yeah, his class has performed. Everything in his is better. All of his numbers are better. However, he's drawn it with a ruler. So I'm going to try and incorporate that in the best words as I can. My English is terrible, so please bear with. So I'm going to say I agree. I didn't spell agree right, did I? Oh my gosh, I told you my English wasn't very good. So I agree, Josh is median and his lower quartile and upper quartile are all higher, or the same really, than Sarah's. His interquartile range is smaller. So majority did better. I need to say, however, his data is less accurate as he has used a ruler. I think this is going to be my pet hate. So he's used a ruler for his cumulative frequency diagram. But if you were just going on data, then you would say, well, look, it speaks for itself. His median's higher, his lower quartile is higher, his upper quartile is higher. He has a smaller range. The interquartile range is smaller, so it means it's tight knit. But that graph is not right. Don't join up your cumulative frequency graphs with a ruler, people. Just don't do it. Okay, so I actually haven't seen the mark scheme, so I don't know if my wording is okay for this, but we're going to assume it is.